So the reason I made this a warm-up is especially that second problem, it can get a little confusing with which formula to use. Remember, we had the one that had the a sub 0 with the e in it, and then we had this guy. Number 3 at the top, it is compound interest formula that you're using, but it's a little different from Friday because we have to solve for p. We're not given p. So setup looks something like this, and then all this parentheses stuff to the right is just multiplied by p. So you can figure out whatever this to this power is in your calculator, and then just divide it over is how we're getting that p value, and then we're just rounding these 2 decimal places. At the bottom here, we're using that y equals a times b to the x formula when it's a percent of its current value. If you see that something is continuously growing or decreasing by a certain percentage, that's when you would use the formula with the e in it. That represents a constant rate of growth or decay. If you see that word, that's how you know to use that one. Okay. Also remember the b value here. Think about 100 is like our baseline, right? If we're growing by 15%, I would add 15% to 100, so 1.15. Here we were decreasing by 15%, so I take 15 away from 100, and I get 0.85. Okay. Any questions on either of these? Just a little recap. Okay, so that might help you with a couple math Excel questions when that comes up. All right, so 4.2, 4.3, and 4.4 are the last 3 sections of this class, and they are all about logs. So today what we're going to do is mostly just like introduction to log stuff. How many of you have learned logs before? How many remember logs? There we go. That seems typical, right? Okay, so I'm going to teach it like you've never seen it before, but ideally a lot of this should be review for you, okay? All right. So why do we have logs? Logs are the inverse of an exponential function. So whenever you are solving for an exponent, and that's going to be like a repeated theme for the next few weeks, if we are solving for an exponent, we use a log to do that. So if I said like find the inverse of y equals 3 to the x power, when we did inverses, if you remember from what section was that, 2.9, we switched the x and the y. So it was x equals 3 to the y power. And then we have to get the y alone wherever it is. And then this is where we get stuck with exponents. We don't have like this mathematical model that allows me to pull that y out of the exponent. Common mistakes that people will do when they try to solve for an exponent is, don't write this down, they would like divide by 3 on both sides and then say, well, the 3's cancel, x over 3 is equal to y. Well, if they were multiplied, division would cancel it, but that's not what's happening here. Another common mistake is people will multiply by the reciprocal in an exponent, which if there's a number in the exponent, you can for sure do that. But when we have a variable there, it'll cancel on this side, definitely, but that still doesn't get the y alone, and it actually makes the left side a whole lot more messy. So when we see x equals 3 to the y power, what we decide to do is invent, or somebody invented, this thing called a logarithmic function. And on both sides, they take the log of that base on each side. So all I did here on the left and on the right is put a log base 3. That's how I would read it. Log base 3 of x, or log base 3 of 3 to the y power. Looks like a little sub notation. And a log base and an exponent base that are the same will cancel each other out. So I end up with that log base 3 and the exponent base 3 going away, and it leaves me with just the y. And so this is the big idea behind logs. We want to be able to cancel out that base, and that's what a log does for us, okay? All right, so a couple things with the definition of log that you need to know. A lot of this is actually coming from our exponential rules that we had before. If you have a log base a of x, a is considered the log base again, and it will always be a positive number. That's the same as when we did exponents last week. The exponent base was always a positive number. X will also always be positive, so that's what we're taking the log of. That is actually going to help us get our domain a little bit later. Okay, so let's remember that fact. And a log base cannot equal 1. That was the same with exponentials as well. Think about an exponential function. If I take 1 to a power, it's always just 1. It would look like a horizontal line instead of this exponential growth or decay. So same with logs, it's going to have that same restriction. If I have a log statement, the absolute number one thing that you need to know about a log is how to take that log statement and rewrite it as an exponential statement, and take an exponential statement and rewrite it as a log statement. So highlight, circle, whatever, those two pieces that you see on the right there. So if I see y equals log base a of x, an equivalent statement is x equals a to the y power. So we're going to go back and forth with these a lot. We're going to take an exponent, write it as a log, that lets me solve for something, or take a log, write it as an exponent, and that's going to let me solve something. So notice a couple things here where things are located. The log base a and the exponent base a. So in both places, a is the base, we call it. Remember, the reason we have a log is to get the exponent alone. So if we look at what my exponent here is, y, that's always alone in your log statement. And then what your exponent is equal to is what we're taking the log of. Now this is where the Ben the bunny, log bunny, comes into play. If you have, let's see, how did they write that? Log base b n equals e, b e equals n. Okay, so Ben the log bunny helps you write one to the other. So you can see base exponent equals a number. That's why his name is Ben. And then the log bunny. See it? Bunny. Okay. So remember Ben the log bunny. That'll help you write one to the other. Okay. All right. So let's practice a little bit. We're not going to do all these together. We're just going to do a few together, and then you can try some on your own. So let's do the one on the top left. I have 2 to the 10th power equals 1024. My job is to write this in logarithmic form, so with a log. All right, so when I write it with a log, it's going to be log and then a base, a subnotation. What should my base be? 2. It's going to be the base of whatever my exponent is. Then remember, why do we have a log? We want to get an exponent alone. So what do I need to get alone here? 10. That's going to go on the other side of the equal sign. And then what I'm left with, 1024, is what we're taking the log of. So I would read that log base 2 of 1024 equals 10. It means the same relationship as the exponential form that we started with. It's still telling me that 2 to the 10th power gives me 1024. It's just a different way to write it that's going to make it easier to solve for things later. Okay. Let's look at the one right below it. Log base 2 of 64 equals 6. So this is a logarithmic statement. I want to write it as an exponent. So we're going the other way now. So when I write it as an exponent, what's the base of my exponent going to be? What's my power? Equals 64. Perfect. Okay, you guys, real quick, I'll give you like, I don't know, a minute and a half. Try the other 4 at the top. All right, let's check them when you're ready. Here are 4 answers. Remember that middle one on the bottom there, a 1/2 power is the same as a square root. So that's why that relationship is true. If I take the square root of 9, I get 3. If I saw like a 1/3 power, it's a cube root. Some of those things are going to pop up against some of our weird sort of exponent rules. Okay. Oop, I wrote that one backwards on the last one. Hold on. Wait, did I? No, I didn't. I'm okay. I'm questioning myself for a second. We're good. All right. Any questions on the top 4? All right, let's look at the bottom ones now. Evaluating a log. So evaluating a log, figuring out what a log is equal to, is just finding the exponent. So that's what we want to remind ourselves. If we're trying to figure out what is a log equal to, we are always searching for an exponent, okay? So if you want to, in these problems, you can make it an equation, say equals x, and our job is to find x. How we find x is we want to think about the relationship this means in exponential form. So if I write this as an exponent, like you just practiced, it would be 3 to the x power equals 9. Okay, Ben the bunny. So now, these right now are meant to be problems that you should be able to do in your head. When we get to section 4.3, we'll have some formulas that we can put in a calculator, even a basic red calculator that will do this calculation for us. But for right now, you should be able to do it in your head. 3 to what power gives me 9? 2. So that's our answer. The log evaluates to 2. 3 to the second power gives me 9. Okay, so let's look at the next one right next to it. So I can say, if I want to, equals x. We'll do that first. And then I can write it with exponents. So 9 to what power is going to give me 1/3. So sometimes they're going to get tricky with the fractions. If you don't like the fractions, think of it as just like a reciprocal first. If I said 9 to what power gives me 3, could you do that? 9 to what power gives you 3? Now, if I do 9 to the negative first, I get 1/9. So a half will give me a 3, right? Because what's a half power the same as? Square root, okay? But I want it in the denominator, so that's where you guys are right about the negative. A negative exponent will put something in the denominator. So I want a 1/2 in the power because that'll take the square root of 9 and give me 3. And I want a negative in the exponent because that'll put the 3 in the denominator. So that's my answer, negative 1/2. Okay. All right, let's look at the next one. Log base a half of 32 equals what? So equals x. Write it as an exponent. 1/2 to what power gives me 32? Again, if you don't like the 1/2 to start, think about it as a reciprocal 2. And then you could even do a little guess and check if this one gets a little big. 2 to what power would give me 32? 5. 2 to the 5th power. 6 is close. That's going to give me 64. 2 to the 5th power will give me 32, but the 2's in the denominator. So how do I adjust? Make it negative. Negative 5 is my answer. Okay, last one of these. Log base 7 of 1 equals x. Okay, I'm going to write it with an exponent. 7 to what power gives me 1? What kind of exponents always equal 1? 0. It doesn't matter what that log base is. If I said log base b of 1, your answer would be 0. Anything to the 0 power is always 1. Any questions so far? Is it starting to ring a bell? Maybe a little bit? Okay. All right, so let's try these. So they've already set up the equation for us, which actually is a little bit easier than the ones we were just doing. All we have to do is put it in that exponential form first and then solve if necessary. If I wrote this one with exponents, what would it look like? What's the base? What's the exponent? Equals x. I'm pretty much done, right? 2 to the 3rd power gives me 8. There we go. Okay, let's look at the next one. Log base z of 125 equals 3. Let's write it with exponents. Z to the 3rd equals 125. Okay, now here, my exponent is not a variable, it's a number. So how can I get rid of that 3rd power? I can cube root, or I could do 1/3 power. They're equivalent. So cube root's easy enough. Cube root. Anybody know what the cube root of 125 is off the top of their head? 5. Yep. Okay, see if you guys can do the 2 at the bottom now. First step, write with exponents. Second step, solve as needed. Okay. On the bottom left, y equals -3. Good. What about the one on the bottom right? There's another answer too. -2. Yeah, there's 2 answers to that one. So when I write with exponents, I get 3 to the 0 power equals 1, and we know anything to the 0 power, or equals the quadratic, sorry. We know anything to the 0 power is 1, and then we know how to solve a quadratic. We've got to get it equal to 0. In this case, it factors, and then our factors give us our 2 solutions in that case. All right, what questions do we have here? Anything? Okay. Okay. So the next slide, you don't have to write anything down on here. talks about a couple properties of logs, and then it actually, in all three of these little boxes, writes the same 4 properties 3 different ways. So what you see on the top left is just the generic property. What you see on the right is when it has a base 10, and what you see at the bottom is what it looks like when it has a base E. So base 10 are what we call common logs. So just like a square root, you don't see the little 2 next to it. We just know if we see a square root that it is a square root because it is the most common type of root. Same thing with a log. We don't see a base 10 written because it is the most common type of log. That's why it gets its name, a common log. So if you see a log without a base, you can assume that means log base 10. Most of the time they're not going to write that there for you though, but you can always stick it in if you need to. And then this is the same relationship we were talking about, right? A log is an exponent is a log, so nothing new there. These are a couple of our exponent properties in disguise. If we look on the top left there, let me write that down actually. If I take those first 2 properties and I write them with exponents, you're going to see it's actually just an exponent rule that we already know. If I write that first one with exponents, it's a to the first power equals a. We know that, right? Anything to the first power is itself. If I write the second one, a to the 0 power equals 1. We already talked about that. Doesn't matter what the base is. If I take it to the 0 power, I get 1. If I write the third one with exponents, it looks like a to the x power equals what's inside the log a to the x. It just gives me a true statement. And if I take the fourth one and write it with a log, it's log base a of x equals what's in my exponent, log base a of x. I just get the same statement twice. But these 2 at the bottom especially are helpful. This is kind of what I mentioned we were doing that inverse problem to start here. If I see a log base and an exponent of the same base, they cancel. Here the log base a and the exponent base a cancel and leave me with the power. Here the base exponent a and the log base a again cancel and leave me with x. So if you ever see a log base and an exponent of the same base, they cancel and leave me with whatever's in the power, which is what we're seeing like here. Okay, if I say log base 10 of 10 to the x power, I get x, because the 10s cancel. Same thing here, they cancel. The other type of log that we see most often is what we call a natural log. A lot of people think this is an I. When you guys are doing Math Excel, it's a log, L, lowercase l. Okay, if you type in an I in Math Excel, they will for sure mark it wrong. Okay, so instead of log base E, we see ln instead. Okay, but if you see ln, you can always rewrite it as log base E, and then these are all those same properties written again. So really this slide tells us a couple of things about how we can cancel out a log, but more importantly, that common log we're going to see. If we don't see the base, we can put a 10 in, and then if we see an ln, we just remember it's a log base E, and then all the properties hold from there. So on your next slide on your paper, these are quick little calculations. If I see log of 1,000, okay, no base, but I can put a base there, 10. And then if I want to evaluate this, I want to remember this means 10 to what power gives me 1,000. When we're evaluating a log, we're finding the exponent. And again, this is meant to be something you can do in your head. 10 to what power is going to give me 1,000? 3. Yeah. When you have these bigger ones, you can just count the zeros. 3 zeros, third power. Okay, so if I had like a million, that's 6 zeros, so it's 10 to the 6th. If I see a decimal, okay, so I've got log base 10 of 0.01, I prefer to write that 0.01 as a fraction because it makes the problem easier to do in your head. 0.01 is 1 what? If I were going to like read it. 1, not 1/10, close. It's 1/100th. If it's 0.01, thousandth as if it was 0.001. But if I write it as 1/100th, you can see that relationship we were talking about before, right? 10 to what power is going to give me 100? 10 to the 10th power? 2. There we go. But it's in the denominator. -2 is my answer. Okay, look at the next one. Natural log of e to the 4th. Okay, so I'm going to rewrite this as log base e of e to the 4th. A lot of times when we see a natural log, there's going to be e in there somewhere. Because I have a log base e and an exponent base e, this is one of the log properties, what happens? Cancel and leave me with 4 final answer. Okay. If I see natural log of 1 over e, again, I can write it as log base e of 1 over e. That means e to what power gives me 1 over e? All I have to do is move to the bottom. A negative 1 will do that. Natural log of 2. So this means log base e of 2. If I write it with exponents, e to what power gives me 2? This one is one that we can't do in our head. So we use our calculator. In your, even a basic calculator, red calculator, graphing calculator, you have 2 buttons that are on the left side. Okay, right next to the 7 and the 4 on your calculator. So ln, when you hit that, will automatically use a log base e. If you hit the log button, this is a log base 10 it's using. Okay, so here you can just type in ln2 if you want to, and it's going to give me an answer. It's going to give me a decimal. And if I round it to 3 decimal places, I get approximately 0.693. So what we're getting is the exponent. E to approximately that power will give me 2. And you could always test it in your calculator. Take e to that power and see that you get about 2. It's giving me an exponent answer. Okay. Any questions on that? All right. So now let's put a couple things together on this next one. All right. The first one is a composition. We've done compositions where we have multiple parentheses. Where do we start? Inside. Order of operations, really, right? Okay, so can we evaluate log base 3 of 81? So we want to think about what that means. It means find the exponent, right? 3 to what power is going to give me 81? 3 to the 4th power gives me 81. So because that log evaluates to 4, the whole parentheses just becomes a 4. So now we do this. Log base 4 of 4. So again, that means find the exponent. 4 to what power is going to give me 4? The answer is 1. This type of question is an excellent ACT question. Okay, a lot of the log problems you see on an ACT are very basic log questions as long as you understand what a log means. And it means we got to find that exponent that's missing. Okay, let's look at the next one. E to the natural log 5 power. I'm going to write natural log as log base e instead of 5. Okay, so I see an exponent base e. I see a log base e. What happens? Cancel, and I'm left with 5. Easy. Okay. Next one, I have a natural log. I'm going to write it as log base e. And then another e. That exponent is x squared minus 3x equals 10. All right, I have a log base e. I have an exponent base e. What happens? Cancel, and I'm left with whatever's in the power. In this case, it's x squared minus 3x. I've still got the 10 on the other side. I have a quadratic. What should I do next? Get it all to one side. Okay, equal to 0. Does it factor? What does it factor to? Close, -5, +2. So my answers are 5 and -2. Okay, the last one is 10. In my exponent, I have log of 2x plus 3. There's no base there, but it's log, log. So what can I put as the base? Base 10. Okay, so I have an exponent base 10 and I have a log base 10. What happens? Cancel. 2x plus 3 is left, and it equals 11. And then this is easy, right? It's just a linear equation. Subtract 3. Divide by 2. Get 4. Look how easy logs are. So easy. All right, so homework. You got 15 minutes now. You can start on it. Is a video on the second half of this lesson. Tomorrow is a Math Excel workday. If you don't want to watch the video tonight, if you prefer to watch it in class tomorrow, you will have the whole period tomorrow to do that, and I can answer questions. This is the handout that goes with the video. The video is linked in the WAG, so all you have to do is click on it. And I think the slide that we just did was like the first slide that was in that video, so we just cut like 3 or 4 minutes off the video. So that makes sense. All right, so second half of the lesson is graphing logs. using the properties we just talked about, and then tomorrow you have Math Excel workday. So 4-1 Math Excel, which is just the exponent stuff, is due tomorrow night. 4-2, this Math Excel is due Tuesday night after we get back from break. So you've got like a whole 8 days on that one. You really don't have to work on the break if you don't want to. Okay? All right, and then that's it. We do cell phone lotto, and we are all set.